Another example of thin wall pressure vessel design. In this case, this is a globe, so the circumferential stress does not really apply. So the inside of this piece only longitudinal stress applies. So T longitudinal stress, that's the only stress you can have. And for the longitudinal stress, the formula is P times internal diameter divided by the 4 T. So if you want to calculate the thickness, then you have to use the allowable stress for the material. So sigma TL allowable, and then you calculate that thickness. Now in this case, it says that the gym ball, typically the inside pressure is 25 psi, and the rubber material, it varies from 1500 to 3500 psi. So we don't know what kind of rubber we get, so to be in safe side we can use 1500 psi maybe. So the allowable stress we can, and this is a gym ball, and now we don't need much factor of safety for this, so we can simply do 1500 psi, maybe 1.5 factor of safety, so that becomes 1000 psi allowable stress for rubber material. So if I calculate this for the 55 centimeter ball or 21.65, so the pressure is 25 psi inside pressure times the inside diameter, which is let's assume 25. This probably just this only the outside diameter. However, the thickness is so small, they're just fine without considering this. So we can say D outside is equal to D inside plus thickness, which is equal to D inside, because this is very thin for that 25 psi. It's not gonna make any difference at all. So then we have this 21.65 inches for, if I convert 55 centimeter, and then 4, here I'm dropping 4, so 4 times the allowable stress, which is 1000 psi. I have calculated that number. Let me get that, 0.135 inches. So this was calculated as 0.135 inches, which is equal to about 3.5 millimeter, if you kind of want to visualize how small this thing is. And then for the 65 centimeter, you can simply do 25 times the diameter, 59, divided by 4 times 1000 psi, so that I got 0.1599 inches, which is equal to about 4 millimeter. And then T75 I have calculated for the 75 centimeter ball, 25 internal pressure, and then the diameter is 29.52 inches divided by 4 times same material, 1000 psi allowable. I have got 0.1844 inches, which is about 4.5 millimeter. So these are the thickness you need for these different size balls. Now the next question asking, should be the price, oh that's a typo, should the price be higher for the larger ball? Of course, because the thickness increases, diameter increases, so total material you're gonna spend for larger ball is gonna increase, so it will cost more, so you definitely charge more for the larger size ball.